Hello friends, this is Rami from NASA in Arabic, and this is a test stream. We are going to test a game called Kerbal Space Program. As you can see here, we have on the launchpad the Russian Soyuz version 4, or a Kerbalized version of the Soyuz version 4. Ready to launch. Is the sound clear? Is the video clear? If everything is clear, we are clear for launch. Okay. Now, the Soyuz is one of the most reliable rockets, space rockets. Please ask me questions in the chat so I can, and send me feedback in the chat, because I need to know if the feed is going through, if the sound is alright. And now we engage the stability system, and we will launch with full throttle. 3, 2, 1, ignition, and we have liftoff. Of course, this Kerbalized version of the spacecraft is a bit not stable, if you want, wobbly when you try to go transonic. We will see that it's already wobbling, and we are still below 80 meters per second, and it's wobbling all over the place. So hope we don't explode, though I have a feeling that we will. It's wobbling too much. Please send me feedback in the chat if you get this. In order to get to orbit, of course, we tend to go up and sideways at the same time. Up to escape the friction and the heavy atmosphere that will affect our speed, and will reduce our speed and prevent us from getting into orbital speed. And sideways, because to go into orbit from the word orbit, it's to be a circular motion, so we have to go sideways. I will perform a bit of a roll here. It's not working as it should be. Okay, never mind that. How much is the frame rate? Here I get that everything is alright from the stats I have here, but I'm not sure. Now we are 7,500 meters high, and we will start our G-turn. G-turn is just to try to smoothly transit from going upward to going sideways, because we can't do it in a sudden, and we can't delay it more than 10,000 meters, because it would waste a lot of fuel to perform the same orbit. Now I'll try to commence my G-turn because it's taking longer than it should. Oh, my controls are on a different window, that's why. The RCS is struggling. Those little buffs you see, they are struggling with this ship to guide it into a new inclination. Anyway, the orbit will not be equatorial as planned before because I lost control for a minute, and it will be a bit inclined. I'm trying to correct it as much as I can without wasting a lot of fuel on that, because we don't care about the precise orbit right now. We just want to get to the orbit. Now I am going with 45 degrees. My attitude now is almost 45. It's 50 actually, 50 degrees. And now I will see my periapse. This is the map, and oh, we lost the we ran out of fuel in those boosters, so we will get rid of that. This is the safety mechanism. We don't need it anymore. We are safe. We are high up in the atmosphere, and now we will let go the... It is stuck, I think. We let go of those boosters. It's a really amazing view when you see them going out like that, then bumping each other. Now back to the orbit. This is the orbit, and my highest point now is 60,000 meters, so I need to get a bit higher. And let's keep this 45 degrees. Please talk to me in the chat if you are joining. If you are watching me, please comment and ask me questions in the chat and give me feedback if you get my voice. Now this is the orbit. We are starting to get higher and higher, but we are going to... Oh, we are going through an eclipse actually. And that's an amazing thing. That's a very amazing thing, which is the moon, or moon, is now going into an eclipse, and we are passing through that. Now we can take a picture of that, I think. Wow, that's cool. I'll take a print screen. Now of course we are trying to lower our angle of attack, or it's not angle of attack because we don't have wings at this altitude. It's the attitude. We are lowering it down, and now we are almost horizontal, trying to be horizontal to... We are now high up in the sky, and that's good. We will throttle down. We will throttle down, and we'll try to keep it this way. We'll throttle down. Oh, okay, good. Now we are 66,000 or 66 kilometers, and our highest point is above the what is regarded as the end of the atmosphere, which is the 70. Now we're 88 kilometers. please give me feedback about the video, if you can see it, if it's clear. And I think we would start the circularization burn. We need to circularize our trajectory and our orbit. Now we will give it full thrust. Okay. Here we are, and that's where we started. That's our launch site, and we are now high up in the atmosphere. Please tell me if you get the feed, if you get the video or not, if you hear my voice or not. Please type in the chat who's with us right now. I can see 2 watching, but I don't know who are they. Please talk in Arabic or English in the chat. فيكم تحكوا عربي أو إنجليزي بالchat. And now I am 89 kilometers, trying to circularize it faster because I'm trying to. I'm starting to get close to my apoapsis. They call it apoapsis here. I don't know why. Okay, now we will get rid of this stage, and the atmospherical it's stuck in a bit. Okay, good, we got rid of it, and from the engine cover, and we are now pushing for circularization. Oh, we are falling already. We are falling already, but we are so close to an orbit. We can make it. We wasted a bit of fuel. It wasn't the most efficient way to go to orbit, but it's a good one. This is our they have different names for it, and I get really confused. They call it here in this program apoapsis. And this is the preapsis. Okay, the preapsis is rising. We are rising our preapsis, and now we are officially in orbit. We will circularize, and now 80 by 96. That's good. 80 by 96. That's good. Now we are in orbit. If you watch this, please say so in the chat and ask me questions. Do you want to try an EVA? We will have to move one of the 3 astronauts are in this pod here. We have to move them to this one here in order to get out of the hatch. So we will try to do that after we do a bit of a roll here. Oh no, the other side. Okay. Now those are the RCS. Okay, that's too much. Okay, we will try to correct. In space, whenever you try to move one way or spin one way, you can't stop. You will keep spinning because there is no friction to stop you, so you will keep spinning until you go the other way. Now I will move one of them, transfer crew. I will move let's say useful or Shernan Kerman will go in an EVA. Now he is here. Now Shernan can go in EVA. Can't exit. Why? Oh, I need to move it first. Now he is here. Now I will give him an order to go EVA, and will light his lights. Okay, good. Now here is he. Now you are clear to let go of the station. Space. Okay, and here he is. Floating in the space in the most peculiar way, as David Bowie says. We will check the engines. Everything seems alright. Everything seems good. Okay, now we will go back to our capsule. Easy and slow. And port. Okay, now we will open the solar panels and the communication antenna, and we are online and in orbit. I think it was a really successful mission, another successful Soyuz mission. Now we will move along in our orbit, and let's go to the other Soyuz we have in orbit. And those three astronauts here need to land now. Welcome Najwa. Hello Najwa. Can you see my chat replies? Yes, I can see your chat replies كستا. نجوى عم نجرب بالإنجليزي بس بمجرد تيست، عم شوف اللعبة إذا شغالة أو لا. طبعا we are in the dark side now. That's why we see nothing. We need to turn on the lights. We are on the dark side of Kerbin. And نجوى راح عليكي كسوف طبعا. راح نروح على الجانب المضيء من كيربن to the let's fast forward to the day side, and it's an amazing orbital sunrise. You see it? It was amazing. And now we will try to plan a landing. We will land here as close as we can to the KFC, the Kerbin Flight Center, or KSC, Kerbin Space Center. I forgot the name. I should start the deorbiting burn right about here, so I will point it to anti-prograde or retrograde, sorry. I will point it to retrograde with RCS. That's really good. Please ask me questions. اسألوني أسئلة بالشات، ودائما خبروني إذا الفيديو واضح والصوت واضح، عم بنتق أو لا. If the frame rate is good or not, please tell me in the chat and tell me if the voice is okay. I will try to go here, to fast forward here, and now Valentina and who else is here? Only Valentina. Okay. She's alone in this Soyuz capsule. Now right over this coast here, I should start my deorbiting burn. Okay, now we are 96 kilometers high and we need to go down here to 0 or to sea level. So we will start now. Those have really slow thrust to rate ratio, so I don't think we can make it. We will end up in the sea because those are very efficient engines. They don't waste a lot of fuel, but they don't have really enough pressure. I'll try to turn those in. Okay, we can raise the thrust limiter here, but we are destabilizing our burn. Okay, now it's better. Okay, and we are ready to cut the engines in 5, 4, 3, 2. Give it a bit. We need some more. Our speed is really high, so we need to kill it. Okay, that's good. So what we did now is that we reduced our speed to 1500 meters per second. Now we will retract our we should retract our solar panels because we don't want to lose them. Or should we lose them? Anyway, we don't care about them. Let's just detach the capsule. We detach the capsule now, and we will detach also the other module here we have. Okay, and the service module, because we don't need it anymore. We are going back home. We will have fresh fruit now and fresh water. Looks fine to me. Okay, that's what I am really worried about, the frame per second, because the game alone without streaming is really intensive. It uses up all my my frame per second and my CPU usage. Anyway, CPU now is about 60% CPU. That's really intense. Anyway, we are I had to stop the deorbiting burn just a little short because the air braking would do the rest, would do the trick, because now the air would try to stop the capsule as we start getting into the atmosphere. Now we have to balance it because there is a way to balance it, but I don't know how to do that because we are starting to get destabilized. We need to be directly we need to direct the heat shield to the way we are falling. This is the heat shield. It's made of plater. It burns away and takes away the shockwave heat. Any questions? Now this is the re-entry, which is a really intense heat, like up to 2000 Kelvin. Now we are done with that, and we can jettison the shield. It always does that in Kerbin. Now we are falling. We can't. We are still transonic. We are supersonic, and we are getting transonic now. And now we are subsonic, so we can now open the parachutes. But we can delay it a bit because the land is a bit far. We need to fall faster. You wouldn't wait 10 minutes or 15 minutes to hit the ground, so we need to just have it fast. And we landed so much shorter than we should. That's the space center there, and we are here, and our pieces are hitting the ground here. Now I'm 4,500 meters up, 4,000, and my speed is 200 meters per second, and I should open the parachute right around 2,000 now, and this will slow me enough. Now 1,000. Okay, those are hitting the ground here. Now we are falling really slow. Now we can jettison the decoupler, and 7. That will slow us down, and that's good. We landed safely. Valentina Kerman landed safely back in Kerbin after a really interesting voyage aboard the Soyuz, and here she is going down. And she will plant the flag of a really successful mission. Valentina, welcome home. And now we need to light it up. Does it show? EV airport. EV airport from Kerbin's grasslands. I don't think a spacesuit was entirely necessary to get here, was it? She's having a picnic, that's it. And here is our flag. It's the opposite way, so we need to go this way. Yeah, now that's right, from right to left. Now we will rescue her back to the station. Any questions, any problems with the... Oh, why can't I get her back? I need her to go back to the... Why can't I? Ah, now I can recover. I need to recover her within the capsule. I can't recover her alone outside of the capsule. Please, if you are watching, please type anything in the chat. Give me feedback in the chat. And I see something went black. Yeah, it's loading. And she is ready for the next assignment. That's good. Now let's go back to the three friends, the Kerbinauts we left in the orbit, and of course this is Kerbin here, which is the tenth of the real size of the Earth. This is Moon, which is the satellite or the moon of the natural satellite or the moon of Kerbin. And we have also a small one which is Minmus here. It's small and really yummy. And we also have so many asteroids around us. This is the Sun, Moho, which is pretty hot, Eve, and Kerbin, Tuna, the red planet. You see it? We need to plan a mission there, and it's Ike. It's Moon. And now we will go back to our friends in the orbit, Soyuz orbiting Kerbin, the other Soyuz. Now those are lines of communications with the Earth control or ground control and communication centers. Once we get over the oceans, sometimes in real Earth and in real life, when the ship crosses a real wide ocean, they lose communication while they move from one communication center to another. So what happens is we lose the feed and the signal, and they show us this CGI motion or CGI representation of the spaceship. Now what I'm going to do is this. I'm going to go back to those guys, fly in, and we will try to raise our orbit. We will try to explain a bit of orbital mechanics. Now, here we are. Let's okay, those are the solar panels. Everything is good. We light the lights. Okay, only one light. That's pathetic, but anyway, or two. And now what we are going to do is this. Here's our orbit. It's 98 kilometers by 81 kilometers. It's not actually real circular, but it's good. Now, in order to raise the orbit, what we need to do is this. We need to point prograde, okay, and we will push prograde, and we'll see how this will affect our orbit here. When we push prograde, prograde means the way we are moving, our speed vector, or our like forward, not backward, to increase our speed. Now our orbital speed is 2200 meters per second, and this is the moon, and this is this is Moon, and this is Kerbal, the sun of the Kerbal system. Now here we are, prograde, pointing exactly prograde, and we will hit full throttle now, and we will go to map to see how that affects us. Look at this. It's rising. It's 170, 180, 190, and 200. We can keep pushing, and it's now 300. We raised our orbit this way. We can raise it some more. Let's raise it a lot. See if we can get a moon encounter, but I don't think we can. But I mean, I don't think we have the delta V enough to get to the moon. Nobody is talking in the chat. احكوا بالشات حتى لو عربي مو مشكلة، يعني احنا عم نجرب بس اللعبة، مو شرط عربي وانجليزي. عم نجرب اذا بتبين واضحة او لا. هل صار our orbit now we need to stop I think, because if we run out of fuel we will get stuck in this orbit forever, or until they send we send a rescue mission. Now this is the new orbit we have. It's now 1500 kilometers by 96 kilometers. This stayed the same. The point where we started our maneuver, or we did our injection, stayed the same, and this one is higher. This is what we call what they call it, I forget the name in English. مدار انتقالي. To move from this low orbit to a higher orbit. What do they call it? I'm still listening. Hello, Kester. Yeah, please just give me feedback. Talk to me in chat, whatever comes to mind, whatever you see. What's the word for inter orbit, interstellar? Not inter. It's like inter something orbit. Okay, Rawan, are you watching? Yeah, what do they call it? Hi, Kesta. Say it again. No, I'm reading. That's good. But tell me the word for the orbit when you move from a lower orbit to another to a higher orbit. It's It's not interstellar. It's transorbit. I forget the word. Okay. It's really easy and stupid word, by the way. Transit orbit or something like that. Okay. By the way, this is this transfer orbit. This transfer orbit is maneuver is called Human maneuver, which is to raise our what do you pronounce this? Like, why do they call it in Cuban apoapsis? It's preapsis and apoapsis here they call it. Anyway, it's transfer orbit. Very vague memories of level physics. Yeah, A-level physics class coming back now. Sure, that's what I'm here for. Now we will move to this side of Kerbin. This is what the Tesla Roadster of Elon Musk did. The Falcon Heavy did such a burn here. Then they coasted in the Allen the Allen belt, which is a really high radiation belt around Earth, and they coasted like this and showing us pictures of the car. Then when they got here, I will try just to grab it. When they got to the farthest point of the orbit, they burned again to go into a transfer orbit into Mars, or into Mars orbit. And they pushed it to the till they ended all the fuel they have. They finished all the fuel they have and ended up with an orbit far beyond the orbit of Mars, which is already was planned to push it to the full throttle anyway. Now, as we got to this far point, now we will have to point prograde again using the thrusters. We need thrusters to move in the zero gravity because there is no wings or nothing to push against. Transit orbit. It's transfer orbit. That's the word, Kista. Yeah, now we are ready to do the second part of Hohmann maneuver. Hohmann transfer maneuver. Now we will point prograde and we will raise our preapps starting now. Okay, now look at this. We are raising this and we are circularizing our orbit. We keep pushing until you are in a circle. But this way we will get stuck in the orbit, by the way, because the delta V we have here is hardly enough to just circularize our orbit. We will not be able to land back in Kerbin. Now this one is 1500 kilometers. We need to go to 1500 kilometers. Now we can thrust down and almost now. Let's go this way. Drop here to the exact point of Abuapsis. That's a stupid name. Now we will give it a bit of thrust and we'll rub it a bit. Now okay, we are starting. That's a really circular orbit now. Now a really circular orbit we have here. Okay, I can see that there is a problem here. Someone is telling me there is a problem. I will check it out. Is it better this way? Okay. Now transit. That's good. I think this one is better this way. Okay. Now we will go back to our friends here. They need to land and we need to get them this way here. If we need to land on the other side, up here. If we want to land in the bright side, we have to move to this side here and lower our orbit. We hardly have enough fuel to do that anyway. We are on the dark side. Sorry for the... Now we will try to land them, but I don't think we have enough delta V to land them. Okay, Now that's good. Okay, I think that's good. Now we will just do it full burn. Okay, full burn, deorbit burn. Now we are lowering this side. When we slow down from this side, we slow our speed from this side. We lower our orbit or our altitude from this side, from the opposite side. That's how orbital mechanics work. Now we are out of fuel from those tanks, and we need to separate them. Now we will turn on the other engine. I think this will land us. We just need to go within the atmosphere, and the atmosphere should take the rest. But this now we will suffer from higher re-entry velocities, and that's now we are getting deorbiting. Okay, higher entry velocities mean that we will have not 3 times the heat. It's like 64 times the heat, because sometimes when you just lower it for, let me calculate it. It's times it's like if your velocity is 1 or 2 meters per second more, your heat would be 8, because it's 2 times 2 times 2. It's the quad factor, or the cubic factor of the cubic factor of the speed you enter. Anyway, we need to get a bit lower than 60, and if we go too low, we will end up hitting the atmosphere too hard, and we will burn actually. So we will try to do it this way. Do we have enough monopropellant? Yeah, we have. Let's turn it off. Let's go to this side, to the bright side. Up here. And now we are coming to the right side. What is the formula? I am just forgetting the words in English right now, and that's really like the most silly words you can ever imagine. أبيخ كلمات بالإنجليزي صرت أنساهم. Another sunrise from orbit, which is amazing. And this is an eclipse, a Soyuz eclipse. When you time a number by itself 3 times, it's the cubic, right? The cubic, it's cube. So the heat increases the cube times the increase of speed. Now we will have to point to the other way before we get into the atmosphere, and the atmosphere will control our descent, and we will the aerodynamic forces will not allow us to do any maneuvers such as these. Now I think my speed is 2700 meters per second, which is really high. Can you see the numbers? Kista, can you see the numbers? اللي بالعربي يحكيني عربي مشان احكي معه عربي كمان، يحكيني بالشات مشان جاوب عربي. Can you see the numbers? Yep, that's great. Now we are entering the atmosphere, and no, we are still it's 86. Once we are down to 70, we are starting to enter the atmosphere, and we will lose our orbital velocity. Now this is 82. This maneuver is called aerobraking, which is to go down into the atmosphere and let the air stop you instead of using your engine to do that. We can do that in Kerbin, we can do that in on Earth, but we can't do that and we can do that actually on Mars, and it's not that effective in Mars, but it's good, it saves some fuel. But we can't do that on the moon because there's no atmosphere on the moon. Top right corner, there is a delay between me inputting chat and appearing on the video. That delay is I think your delay. I think it's not mine. There is no delay on my behalf, only because you are a bit behind the live stream. If it is only 1 or 2 seconds, that's normal, that's YouTube. Now I need to let go of those before they explode, but I will try to see if I can survive this. I will let it burn. I should detach this one, okay, but I'm not going to. I'm going to see if what will happen. Now we are hitting the atmosphere and those solar panels are heating. We should actually retract them. We can retract them, but I'm not going to do that. Or should I? Let's retract this one. It doesn't want to be retracted. Anyway, we are starting to burn. Haha. And while burning, we are losing speed and losing our orbit. It's coming down now. See it? It's coming down here. Anyway, now we are going to lose the solar panels. They will explode. Hopefully they will explode safely in this game, not like in real life. They would shatter the spaceship with debris. Anyway, we are still within safe limits, and we have extra fuel. We can reduce our speed. We can do it safely, but I'm just trying to show you how it feels like when you enter the atmosphere this bad, or from a higher orbit. It will start going. Now we are still not captured. That's weird. We are going for another orbit then. We will just splash out of the atmosphere. We are splashing out of the atmosphere now. We didn't go deep enough into the atmosphere to lose enough speed, so we splash down and we'll go for another orbit. We lost nothing so far. That's a good news. Let's do it again. Do you want to do it again? Let's drop here. We can't trap within the atmosphere. We'll need to go out of the atmosphere first. Okay. Now we are out. Let's trap here. As you can see, we are going back to the dark side. Oh, it's more like 10 or 20 seconds. Aha. Between me inputting chat and it appearing on the video side, by the way. Okay. Can you read the numbers of the speed and orbit and altitude? I can make them bigger and smaller, but they would just take more space of the screen, which is a really precious space when you are trying to keep your staging, keep your info everywhere. So I again retrograde. I'm going to deorbit, and let's do it. Now 30, 20. 20 is good. 20 is more than good. It's like too deep now. We will hit the atmosphere really hard. Okay, we are now sure to be captured. Okay, let's get it trap here, and where is the planet? Here's the planet and another sunrise. Wow, that's cool. Mean buttons left corner. Yeah, like the speed. You see the speed, meters per second. Just the nav ball. You see the nav ball. There are numbers on top of it. Yeah, I can barely read speed. it's really important to read speed actually. So I'll try to make it a bit bigger. Let's see. What it's are you watching this on the 40 dB? Now full scale. It's full scaled. Now we can do it like this. Is it better like that? 120. That's good. I think that's good. You can read the speed and you read the degrees. Yeah. Okay. Now I will have to just let it go into the atmosphere. This time we will lose the solar panel for sure. And we will lose the engine and all of those stuff. هي حرارة إعادة الدخول الغلاف الجوي. It's getting heated. And we'll see very cool stuff here as they start to explode. Yeah, that's what I'm talking about. We lost 2 solar panels and we have a lot of fuel here to do a big explosion. Fuel tank will be. Now we are entering the atmosphere with 27,000. We lost the antennas. Antennas broken by aerodynamic forces. Now, when it's plasma like this, they lose communication in real life. They lose communication with the Earth because this plasma around it, which is produced by the shock wave, usually heats to really high temperatures compared to sun, the surface of the sun temperatures, and they lose all the communications with Earth. So we can't tell if they can't call home, they can't tell we are safe or we are burning, they can't do anything until this re-entry ends. Now of course we can see that we are losing the orbit now. We are going down. Okay, let's watch this. It's a really nice place to land here. Overheating, as you can see. It's going red. And I'm really surprised it didn't explode yet. It should, because we are still in the orbital velocity. We are 2000 meters per second. Now we are dropping down the orbital, suborbital velocities. Now we are losing orbit, I think. Yes, we did. Exactly. Now we are hitting harder and thicker layers of atmosphere the more we go down. We are now 27 kilometers up and 1800 meters per second, which is 1 kilometer 800 meters per second, which is really fast. It's like 3 times or 4 times the speed of sound, I guess, or three times. I'm not sure. It's about that. 3 or 4 times the speed of sound. We are still burning. Now we have a heat shield. If we just let go of those, we have a heat shield. Heat shield would oblate and save us from the fire, but I'm just doing it the wrong way now. I'm just trying to show you how cool it is when stuff starts exploding, and they are not exploding, and that's really unfortunate because we need to see things exploding. Anyway, should we just let go of that or not? Let's do. Wow, that's cool. Okay, now we can it's safe to open. We are now subsonic. It's safe for us to open the parachutes, but I'm going to wait. Going to land it a bit hard this time. Let's think. They are smashing down the ground. Now this is our shadow. Now this is our shadow. Good. That's good. Trying to see it from an angle that would allow me to know the distance. This one is exploding now. Now this is our shade here. Let's go down 900 meters, 800. Now I think we should stop by now. There's something that's going to explode, and it did. Okay. Now we are 500. I'm going to turn on the soft landing engines. They are made like the real Soyuz. To just now let go of this, and it didn't work like it should. It should do like this, but I didn't. Anyway, that's a really good landing anyway. Thank you so much for watching, and I'm really happy that it worked out. It's fuzzy rather than too small. Fuzzy, not too small. Fuzzy, it's you should just set your settings, your YouTube settings to higher. You should choose the settings to be a bit higher. Anyway, we got safe, but we did a mistake. We had a really bad mistake. Can you guess what that mistake was? We forgot a carbonite in the other capsule that is not supposed to land anyway, and exploded out there. We lost an astronaut just because we forgot to get him back into this capsule again. Oops, I usually don't lose any of my carbonites at all, but this is a really so stupid and silly mistake to lose an astronaut this way, just to forget to get him back in. And كان معكم رامي عماد لناسا بالعربي. Thank you so much for watching, and I think this was a successful test. We will be ready to go live tomorrow. راح نكون معكم مباشر إن شاء الله بكرة على إطلاق Falcon 9 for the Falcon 9 launch tomorrow about 4 p.m. I think. So just subscribe, click the alarm button or the notification button, so you can be notified whenever we are going to be live. And شكرا كتير لمتابعتكم.